Yes, so continuing from our previous video of the base concept of basic probability theory, moving on to inferential statistics. I had already given an idea in the other video. Always remember, you study your small group. You can do basic statistics on it, mean, median, mode, standard deviation, mean deviation, all of that, describing the characteristics of that small group, descriptive statistics. But the moment you want to go above and beyond your data, now using the small group, you want to make claims about the larger group which you have not actually fully studied. But using only this small sample, small group, you want to make inferences about. That is why the word inference is used. Inference is used when you actually make claims about something which you have not actually studied. Inference is something which is indirect. So you are indirectly making assumptions about the larger group, which means you are moving on from a small sample, a small group, to making universal insights, generalizations. That is where, remember, in class I had mentioned you cannot observe the entire population directly. See, take one example, one good example. Take social work students as your subjects. Stress levels of social work students in India. Suppose 5 lakh social work students are there. Can you go to everyone? No, not possible. That scale is huge, not possible. Instead, what will you do? You will take a good representative sample of maybe 500 students from all over India, and then you can make scientific conclusions. If you do that properly, using that probability theory, mathematics, whatever you got from your small group will automatically apply to your larger group. That is the basic theory of the basic probability theory. Always remember, your small group, you do hypothesis testing, and you make generalizations regarding the population. So what is inferential statistics? It is the branch of statistics that uses uses sample data to draw conclusions or make generalizations about an entire population or a larger population. So always remember, it builds a bridge from the known to the unknown. What is known? Your small sample which you have studied. The unknown is the larger population, which you don't have a conclusive idea about. So always remember this. Your descriptive statistics is used to observe, describe, summarize your small group, your sample, your existing data. Inferential statistics always goes beyond your data. It tries to uh, project this claim onto your larger group. So then the core question is, in descriptive statistics, you do mean, median, mode, standard deviation, mean deviation, all of that to understand what is happening in my small group. Suppose if I'm only studying MSW students in Kristu Jayanti, what if I want to know what is happening with all the MSW students in Karnataka? Now there is one problem there. Can I trust this result? Can I trust this result that I got only from students, MSW students in Kristu Jayanti, to apply to all the students in Karnataka? Will it go wrong? Will it be true about the whole population? That is where the concepts of basic probability theory, inferential statistics, hypothesis testing, all of that come into picture. So the idea is that descriptive statistics, it is to talk about your sample mostly. But this moves from sample to population. I hope the picture is pretty clear now. So the three mechanisms here are, first thing is you take your sample, right? You take your sample and you try to generalize it to the population. Two things can happen here. First one is your the larger thing is probability. Using probability, you are trying to project it, extrapolate it to your larger population. That is where, remember, we studied type 1 error, type 2 error. If your sampling is not right, you can either get false positive or false negative, and this can skew your results. This can affect your results. Now, so that is why there is no way to study to have an idea, have a comprehensive 100% sure idea about the population. You can only study a sample and draw conclusions regarding your population from that. It is our window to the population. Other there is no other alternative. There is no other way to study large groups of people. This is the only way. That is why we do our best to make sure that our approximations from the sample are a good fit for the population. We try our best. Now, always remember, you will never be able to get a perfect sample which exactly describes the parameters of the population also. That will never happen. Some kind of sampling error will always be there. But that is why, remember, I had mentioned the p value, alpha value, and all of that. That is why we have that 5% error margin. Okay, it is always present in research. You will rarely get a sample which completely is according to the which can completely describe the population. So probability, that is why, is always an estimate whether whatever results you got, there is a relationship between social media and loneliness among elderly. Did it happen just by chance in your small group, or is that a pattern across all the elderly in Karnataka? That is what we are doing using probability and inferential statistics. That is where in between these things you have hypothesis testing also. We use probability theory to do hypothesis testing, where you have the null hypothesis, which does not just mean that there is no relationship between two variables, which means that we have a starting point, a fair starting point. Take one example, suppose common height of people. Height of people, we have this idea that height of people in Bangalore, average height is 170 centimeters. If suddenly your sample size says that you got the average height of your sample size 500 people is 185 centimeters, that is a completely surprising result. In that case, the old knowledge null hypothesis that the average height is 170 centimeters would be rejected and your new knowledge would be accepted. That is how hypothesis testing works. But if you get a result where the old hypothesis, the null hypothesis was the average height is 170, but what you get is 172, it is not a surprising result. You will accept the older hypothesis only, the null hypothesis only. New hypothesis is not very new actually. It is not very surprising. It is through this process of testing and refining through which science progresses. So, using this larger idea of probability theory and inferential statistics, you have particular tests, t-test, ANOVA, chi-square, correlation, regression, all of that. We'll discuss all of this in the coming videos. These are your particular tools, but the underlying philosophy, the underlying mathematics is the same. So the idea of inferential statistics, how you draw inference from a sample, do hypothesis testing using probability, and then you either generalize it to the whole population or you reject it, is how science works in general. Okay, and for social workers, this is ultra important, how we study relationship between different variables, whether we compare groups, men, women, or people from different ethnicities, people from different castes, people from different regions, or evidence-based practice. For all of these, that is why, see, how do we make decisions in the social work setting or in the social setting in general? How do you make decisions? How should you bring in certain governmental programs, or where should an NGO spend its money? You take those decisions based on these statistical data. Okay, you have this idea that this concept is related to this concept. So if we come up with a program where we can help people with this concept, it can bring about certain social change. I hope you get the idea. That is why understanding these patterns is ultra important. That is where statistics comes into picture. So inferential statistics in a way goes beyond the data. It allows us to make scientific evidence-based decisions about entire populations only using sample data. That is the most important thing. And the basis for all of this is probability and rigorous mathematics based hypothesis testing. So in the upcoming videos, we'll now discuss particular tests. Thank you.